Hello, welcome to Nanospace, where you are literally the size of an atom. Today, we are going to be talking about chemical bonding. An ionic bond is a bond between oppositely charged ions in a chemical reaction. This happens when the outermost electrons, called valence electrons, of one atom are transferred to the other. The atom that loses electrons becomes a positively charged ion, or cation, while the one that gains electrons becomes a negatively charged ion, or anion. A covalent bond is when two anions bond and share their electrons to be stable. They bond because of the electrostatic attraction between the nuclei and share valence electrons. Covalent bonds can have different bonds, such as double bonding and triple bonding. Because of the octet rule, all atoms need 8 valence electrons to be stable. Electronegativity is the ability to attract electrons. Differences in electronegativity can cause electrons to be shared unequally. This difference is called polarity. Polar bonds are when two atoms share the valence electrons unequally. The greater the electronegativity difference, the greater the polarity of the bond. Intermolecular forces are forces holding molecules together. Here are some of the types. Covalent network solid are huge chain-like structures of atoms and/or molecules held together with covalent bonds, like diamond, graphite, and quartz. These are the strongest intermolecular forces. Next are hydrogen bonds. These are polar attractions between hydrogen and fluorine, nitrogen, and/or oxygen. Because of the polarity of these bonds, they have special properties, like being less dense when frozen, high surface tension, and higher melting and boiling points. Up next is dipole-dipole forces, attractions between opposite ends of polar molecules whose strength increases with polarity. Lastly, London dispersion, which are attractions between nonpolar molecules due to electrons. This is the weakest form of intermolecular force.